So in the previous experiment I showed that if I'm rotating the pipe, then the water is coming out. Now my question was that the water is gaining some potential energy, right? I was holding the pipe like that. So if I am rotating, the water is going up, then it, due to centrifugal force, it comes out. But to go up, it needs some energy. Someone has to do work on this water so that this water can gain some gravitational potential energy. So who is providing this work, or who is increasing its gravitational potential energy? Well, the reason is quite simple, that is Bernoulli's theorem. According to Bernoulli's theorem, if a fluid comes into motion, then its static pressure decreases. This is in accordance with the law of conservation of energy. Now there is also an equation of Bernoulli's theorem, but we don't need here. We just need the information of decreasing pressure here. So here's a simple representation of Bernoulli's theorem. See, here is a cup. Here is a cup, and this is a straw. This is a straw. Now the straw has two openings. At this point, I mean inside the cup and outside the cup. Now the part of the straw that is outside the cup is slightly longer than inside of the cup. I will tell the reason why later. Now the thing is that if I fill this cup with water, then you can see that the water cannot reach this height, because the maximum height the water can reach is the maximum height of the cup. Now the maximum height of the cup is less than this part, right? So in order to for the water to rise to this level, a pressure has to be applied. But the thing is that how can I apply the pressure now? Well, there is a simple way, that I will blow air from below this part. I will blow air through this below this part of the straw. Now if I blow air through this part of the straw, then the air above, which is at rest, will actually push this water. As I said, that according to Bernoulli's theorem, if the air comes in motion, or if a fluid comes in motion, then its pressure will decrease. So in this case, if I blow air through this, below this region of the straw, then the pressure here will decrease, and the pressure here is more. The pressure of the air, atmospheric pressure, is more. So this atmospheric pressure will push the water up, representing, verifying that Bernoulli's theorem is correct. So let's test it. I'm filling it up with water. So it works. So this representation proves the point of Bernoulli's theorem, that the pressure of a flowing fluid or a fluid in motion decreases. Now let's come back to the case of the rotating pipe. Now when I'm rotating the pipe, the air in this part of the straw is coming in motion. So according to Bernoulli's theorem, the pressure here should decrease relative to the surrounding air. The surrounding air is in rest. So the air from everywhere, of course from everywhere, starts or comes to fill this region. So the air in this part of the pipe also comes to fill this region, and the water droplet, or the water that is present here, will be pushed up by this air. The pressure has decreased, so the air in this part also wants to fill this region. So this air actually pushes the water up to this part, and as the water comes to this part of the straw, due to centrifugal force, it comes out. That's simple as that. Thank you.